All right, let's get some advent of code. Here we go, day one. Let's see. You're minding your own business on a ship at sea when the overboard alarm goes off. You rush to see if you can help. Apparently, one of the elves tripped and accidentally sent the sleigh keys flying into the ocean. Before you know it, you're inside the submarine and the elves keep ready for situations like this. It's covered in Christmas lights, because of course it is. And it even has an experimental antenna that should be able to track the keys if you can boost its signal strength high enough. There's a little meter that indicates the antenna's signal strength by displaying 0 to 50 stars. Your instincts tell you that in order to save Christmas, you'll need to get all 50 stars. Collect stars by solving puzzles. As the submarine drops below the surface of the ocean, it automatically performs a sonar sweep of the nearby sea floor. On a small screen, the sonar sweep report, which is your puzzle input, appears. Each line is a measurement of the seafloor depth as the sweep looks further and further away. For example, suppose you had the following. Okay, so those are the depths. Indicates that scanning outward from the submarine, the sonar sweep found depths. That and so on. The first order of business is to figure out how quickly the depth increases, just so you know what you're dealing with. You never know if the keys will be carried into deeper water by an ocean current or a fish or something. To do this, count the number of times a depth measurement increases from the previous measurement. There is no measurement before the first measurement. In the example above, the changes are as follows. Increased, 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 decreased, so 210 to 200 decreased. In this example, there are 7 measurements that are larger than the previous measurement. How many measurements are larger than the previous measurement? I am not logged in. Let's get logged in really quick. There we go, that's better. Okay, let's get some puzzle input. So here's the puzzle input. Copy that, and then we're going to go to day one, and let's put that right there. Ooh. Beach ball, come on, Xcode. Really? Not gonna help me out here, huh? There we go. Holy cow. Okay, it's huge. That's why it took so long to paste. 2,000 lines. Okay, so part one is we do let lines equals input dot lines dot map to, I'm going to turn these into integers. I think we do it like that. Boom. Is it just this? Boom. Okay, so we end up with an array of ints. And then we say var previous equals max, the biggest int. And then we're going to say var total increasing, because we're just going to count how many we have that are increasing. Actually, what we could do, yeah, that works. Total increasing equals 0. And then we're going to say for line and lines, if line is greater than previous, then our total increasing goes up by 1, and then previous equals line. Okay, so what this should do is on the first line, there's no way that it's going to be bigger than that, and so it'll skip this, and then it updates previous as we go each one, and then we're going to print total increasing, and then we run it. That should give us an answer. I like that these problems normally start out pretty easy. What are you doing? Are you compiling? What is happening here? Main, day 1, part 1. Are you running? There we go. Okay, hopefully that's our answer. Submit. That's right, continue to part 2. Considering every single measurement isn't as useful as you expected, there's just too much noise in the data. Instead, consider sums of a 3-measurement sliding window. Again, considering the above example. Start by comparing the first and second 3-measurement windows. The measurements in the first window are marked A. Their sum is this. B, its sum is that. The sum of measurements in the second window is larger than the sum of the first, so it is increasing. Your goal is now to count the number of times the sum of measurements in the sliding window increases from the previous sum. Okay, so this is basically the same problem, but you just take them 3 at a time and then compare them to the next 3 at a time. So you can see they've got it marked with the A's and the B's. We're going to basically just take this for part 2. And then what we want to do is we're going to say, we're going to replace this portion. So we're going to say for I in lines.count minus 2. Is that right? Am I thinking about this right? Let's come back over here. So the last I would be this one. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we want the last I to be 0, 1, 2, 3, 4, 5, 6, 7. So it's minus 3. In 0, dot, dot, dot. So from 0 to minus 3, there we go. And then we're going to say value, sum maybe is lines sub I plus lines sub I plus 1 plus lines sub I plus 2. So this will be the 0th, the first, and the second item, and then it moves along. So that's the sum, and then we're going to say if sum is greater than previous, total increasing plus equals 1, previous equals sum, and then print total increasing. I can type total increasing. Okay. Hopefully that's right. I think that'll give us the sliding window 3 at a time. So 1600. That seems odd. Like that feels suspicious. But I'm going to submit it. Hey, it was the right answer. I was saying it seems suspicious because it was a round number, but also really close. So let me give an explanation here, like a breakdown of what actually happened in this problem. So the first problem, what it wanted us to do was look at, let's jump back over here to day number 1. So what it wants you to do is it wants you to find out how many times one number is bigger than the previous number. And so basically what you need to keep track of is you need to walk through the list of numbers that you have, and you need to say, okay, what is my number that I'm on? Let's start here. What is the number that I'm on, and what is the previous number? Those are the 2 things you need to keep track of. So let me shrink this here. So let's walk through the code. This converts the text into numbers. That's all this does. So if you're not familiar with functional programming, map just takes a collection of things. In this case, it's a list of strings and turns it into something else. And that's what this little anonymous function does, is it takes one thing in, that's what $0, that's the name of the variable that goes into it, and turns it, in this case, into an integer. If this syntax looks weird to you, don't worry about it too much. Just know that all it's doing is it's taking our entire text, splitting it into individual lines, so a string for each line, and then the map turns it into an integer, so a new number. Then the first number in our list that we're looking at is never allowed to be considered increasing because there's nothing that comes before it. So the first number can't be increasing. So set our starting value to something so big that nothing is bigger. And that's what int.max is. So this is the largest integer that you can possibly have. Because again, if you're new to programming, every number type has a maximum value that it can hold in the memory that's allotted to it. And so this just says, hey, whatever that number is, that's what we're going to start with. So this is this total increasing. This is the answer to our problem. How many times was the number bigger than the previous number? And then this is look at every line. So we're going to go through every line. Remember, if I option click here, this is our array of integers, array of numbers here. We're going to go through every single one of them. And then we're going to look and we're going to say if the line is bigger than the previous. So the first one, if we had these numbers, would be 199, and 199 is never bigger than whatever the maximum integer is, which is our design. So it would skip this, and then it would say previous is now equal to 199. And then the loop goes to the next number, which would be 200 in this case, and it would say if line, so 200 is greater than previous, which we had just set to be 199, which it would be, then you would add 1 to total increasing. So this is how we're counting. If you're not familiar with this syntax, this just means add 1 to total increasing and then assign it back. This is the equivalent of saying total increasing plus total increasing, or equals total increasing plus 1. It's just a shorthand for that. So it's a way of adding 1 to a thing. So this just goes through them all, and then this prints our answer. Now this does the same thing, but if you remember, it was asking us to do what it was calling a sliding window. So if we look at this as a list, this would be the item at the 0th index, this would be the first index, and this would be the second index. So 0, 1, 2. So if we change our loop to, instead of going through every line, we're going to go from 0 right here all the way to lines minus 3. So lines.count, if you're not familiar, this is just a thing you get used to in programming, that a list, the count is actually one beyond. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 items. But if you look at their indexes, it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you tried to access the 10th index, because there's 10 items, you'd go too far. So it's just a thing you get used to. And so in this case, because we're doing a sliding window, we want to go from 10 minus 3. So 9, 8, 7. This is index 7. And you can see that's the size of our last sliding window. So that's why we start at 0 and we only count up to, in this case, 7. So however many numbers we ended up with, minus 3. And then it asks you, it says right here, sum up the window. So in this case, the first time through the loop, I is going to be 0. So we have line sub I is 0, lines sub I plus 1, so this is 1, and then this one is 2. So that is the equivalent of this, which is 0, 1, and 2. So that's how we get our sum. We've done the same trick here where we set previous to something massive so that the first time through it skips it, and then we update our previous for every loop because we're looking at a sliding window. So we add up these 3, the A's, and then the next window we just take our I and add 1 to it, and then use those 3 items for the next sum. And so that's why we're updating previous to the sum. So the same problem here. This problem just looks at 1 item at a time. This looks at 3 items at a time. All right. I hope you found that one valuable. If you do, stick around. We're going to be doing these problems every single day of Advent of Code. I'll be streaming them at night as long as I can solve them quickly. And as soon as they get too hard for me to solve quickly, I'll start doing them in the morning after, because when you work a day job programming, your brain gets a little fried, and so it's a little hard in the middle of the night to solve programming problems. So anyway, hopefully we'll catch you on the next one. Thanks.